Okay, here we are with question 8. One of those ones where you've got to prove an identity. Now you've got your choices here about how you're going to do this. Clearly you've got to start with the left hand side, I would say. And what might you do? Well, you might not notice that 1 plus 10 squared and think, I need to get this in terms of sine and cos, so I'm going to go straight in for that. So this is 2 sine theta over cos theta, that's the top line, over 1 plus sine squared theta over cos squared theta. Might have started with that, which is 2 sine theta over cos theta over, well, let's common denominatorize that. That's cos squared theta plus sine squared theta over cos squared theta, which is 2 sine theta cos theta over 1 over cos squared theta. So 2 sine theta over cos theta times cos squared theta over 1, which of course gives us 2 sine theta cos theta, because cos theta cancels out, which is sine 2 theta. Up here, what you might have done at this point is you might have said this is the same as 2 tan theta over sec squared theta, because 1 plus tan squared is the same as sec squared, at which point you're saying 2 sine theta over cos theta over 1 over cos squared theta, and you've jumped straight down to that point down there, haven't you? And missed a few steps out. It's up to you. Part 2. In this question you must show detailed reasoning. Solve the equation. So they've given us the identity from the first part. It's now equal to 3 cos 2 theta. So in part 2, we're showing detailed reasoning. So, you know, I'm going to be careful here that I do every single step. So 2 tan theta over 1 plus tan squared is 3 cos 2 theta. And we're going for theta between 0 and pi. It can be equal to each of those things. Right, so we know that from part 1, this is my little bit of detailed reasoning here, I'm going to say that sine 2 theta is the same as 3 cos 2 theta. I am going to divide both sides by cos 2 theta to get sine 2 theta over cos 2 theta is equal to 3, so tan 2 theta is 3. We'll do inverse tan of 3. Inverse tan of 3. Get to the right mode, please. We are still in radians, so we're all right. Inverse tan of 3 gives me 1.249. 2 theta is 1.249 radians. Now we are doing tan. There's my tan graph. That's 2 pi there and pi there. So the next value would be that. Here we are at 3. It's that plus pi. But actually, if theta is between 0 and pi, oh, that's all we need actually, isn't it? 2 theta is between 0 and 2 pi. So I only need to go as far as 2 pi. Now I'm going to divide by 2. So what we got, let's just store that so we can use that again. So store that in A. We've got A over 2. That's one of our values, so 0.625 radians. And the other value is A plus pi divided by 2, 2.20 radians. Both answers to 3 significant figures. Is that all right? Yep, and there we go. And that's maths.